day, everyone, and welcome to Dynamic Cycle Institute, a journey towards circular economy webinar series powered by Taghleef Industries. I am Ambra Stocco, Marketing Communications for Label Films at Taghleef, and I will be your moderator for today's webinar. The DC Institute is a webinar series with TI partners and industry experts with the aim to share advanced know-how to various stakeholders within and beyond the packaging and plastics industry. We would like to thank you for joining us 2 weeks ago in our joint webinar with Recyclas, where we discussed about the methodologies and guidelines that they developed to assess the recyclability of a package. For today's webinar, we are also joined in by Taghleef's Product Manager and Sustainability Advisor, Mrs. Monica Battistella, to introduce our speaker and participate in our Q&A session after the presentation. Hello, Monica, how are you?
Hi, Ambra. I'm doing well. And hello to everyone who has joined our webinar today. I look forward to the presentation as we are joined in by Institute Cyclos-HTP, whose value in supporting the transition towards a circular economy is widely known. The Institute Cyclos-HTP is expert in the classification, assessment, and certification of recyclability of packaging and goods, as well as in research and development in this area. For this purpose, the Institute Cyclos-HTP have designed a specific catalogue for requirements and evaluation called Catalogue R A. They are offering research and consulting services as well, with the aim to help optimizing packaging sustainability by developing ecological packaging designs. Within the scope of their analysis fall also the interaction and effects of other packaging components like adhesives, barrier materials, printing inks, and the like when the packaging goes to the recycling phase.
Thank you, Monica. Before we introduce our speaker for today, we would like to remind you that this will be our last live session for this year. However, we can already announce that we are planning a second Dynamic Cycle webinar series along with other industry professionals that will take place early next year. For this reason, make sure to follow us for all the latest updates on our LinkedIn page, that's Taghleef Industries, and Twitter page, that's @TI_films. In case you missed our previous webinars, they shall be available for preview on our landing page, that's dynamiccycle.ti-films.com. We will be answering your questions at the end of the presentation, so please feel free to type them in and we will try to cover them during the Q&A session. You can click on the below Q&A button, which you can find on your dashboard, to send in your questions. And now, to officially begin, I turn this over to Monica to introduce our speaker for today.
Thank you, Ambra. Our guest speaker for today's webinar has an outstanding and wide experience in recyclability and related certifications. She was first appointed as certified expert on packaging disposal by the Chamber of Commerce and Industry of Osnabrück, Emsland, Grafschaft, Bentheim in 2006. And 4 years later, she was appointed auditor for recycling plans according to the German packaging law. As additional achievement, in 2012, she was also accredited as EU-Surplus auditor according to the European-wide certification scheme for the recycling and traceability of post-consumer waste, an auditor as independent competent institution according to regulation RAL UZ 30. After 6 years in the position of business unit manager for certification and eco-label Blue Angel at Cyclos, since January 2019, she has been operating as Managing Director of Institute Cyclos-HTP. Let us welcome Mrs. Sandra Beckamp.
Thank you for the introduction, Monica. I'm delighted to have the opportunity to speak here today to present what we are doing at the Institute Cyclos-HTP. Since 2011, we carry out now recyclability assessments for packaging and goods according to our own standard for packaging manufacturers and brand owners. Also perform research and development in this field. And due to the high demand that we founded the Institute in 2014 and published our own standard. We work as publicly appointed and sworn experts for packaging disposal, perform expertises for courts and public clients in our role as sworn experts, independently and free of directions. Our standard is an EU-wide audit standard for packaging for all material types accepted by the industry and in accordance with the norms EN 13430 and the ISO 14021. Our work is backed up by almost 30 years of experience in plant design. Due to the fact that one of our founders of the Institute is the engineering company HTP, which has nearly 30 years of experience in plant design, over 100 reference plants are planned by them. The core competencies of HTP cover the entire range of plant engineering for the treatment of waste, including residual waste and packaging, as well as plastics, paper, commercial and industrial waste. The Institute Cyclos-HTP performs recyclability assessments and issues a certificate if the test result is positive. We also perform workshops to train packaging manufacturers, brand owners, and other parties involved. The Institute is a packaging instance also for different packaging manufacturers, means that packagings are tested and accompanied in its development before the packaging are put on the market. The assessments are done for all packaging types, means plastics, fiber-based materials, metals and glass. And we also do some research and development in these fields, do IT developments like our assessment tool, Toolkira, which we would like to evaluate to launch at the beginning of the next year. She is not organized. She is the abbreviation of the Institute Cyclos-HTP for reasons of independence, but the shareholders of she participate as independent experts in panels or committees. For instance, CFLEX, the technical committee, USAT+, and we advise the Federal Environmental Agency and the Federal Ministry for the Environment in Germany. So, for instance, a recent research project is commissioned by the Federal Environmental Agency. It is the review of the effectiveness of the Para 21 of the German Packaging Act and has to develop proposals for further legal development. The project period is the end of 2021. So for the green dot in Germany, per instance, we've also developed a small tool. It's a tool to evaluate the recyclability of packages as a quick orientation. This is, one might say, the little sister of the professional Toolkira, which will be available next year as a software program. Let's move on to how we define recyclability. The term deviation for the recyclability definition should be explained based on a product level. The basis of the spiral is assigned to products that are used for energy recovery processes, like fluff. The higher you get, the quality of the pre-products is increasing. So when we talk about recyclability, we always refer to high quality and material recycling. Our focus is here on the top of the downward spiral, where a substitution of corresponding virgin material is given. Products are here recyclates, regenerates, and blends. For instance, closed-loop recycling processes like bottle-to-bottle recycling processes. But we also take into account second, a lower quality level, means polyolefins, for instance, from yogurt pots or trays that are reused for the production of flower pots or pipes. It's the second loop of the spiral. In this application, virgin material is replaced too. However, its use is limited in coloring or in relation to contact with food. What means ability here? It's our concern to create an environmentally relevant manufacturer's declaration. So according to the standard ISO 14021, product declarations must be not misleading, but substantiated and verifiable. Means the property must be real and not only hypothetical given. We'll need at least one applied procedure on an industrial scale and the proof of a material flow that follows established collection and processing structures. Recyclability as a balance frame should indicate how much recyclate can be generated from a packaging or a good. Means which share of a virgin material may be really substituted. So our definition is as follows. Recyclability is the individual gradual cyclability of a packaging or a product to factually substitute material identical virgin material in the post-use phase. Factually means here that collection and processing structures in an industrial scale are available. In short, recyclability means conformity to the requirements of established recycling processes. The Central Packaging Agency, the so-called Zentrale Stelle in Germany, has created an own definition that refers also to high-quality recycling. So the definition is very similar. You see, recyclability means the fundamental and gradual cyclability of a packaging to substitute virgin material in standard applications after passing all industrial available recycling processes. The next slide shows the current state of the art for a sorting plant for lightweight packaging in Germany. I will not go too much into detail here, but would like to show that sorting is a very standardized procedure in the meantime. This flow chart here is strongly simplified. So we have in modern sorting plants up to 50 different structures, and all relevant steps of the sorting process have to be considered for the assessment. In sorting plants, we have to handle big material volumes. Lightweight packaging, lightweight material has a very low bulk density, so that we have throughputs of around 1,000 cubic meters per hour. Thus, the input material has to be conditioned for subsequent sorting steps via sieving machines. We have separating steps that separates 2- and 3-dimensional material via wind shifting, to magnetic separation, eddy current separation, and the NIR standard polymers are separated. I've picked out 3 sorting steps that I would like to show a little bit in more detail. One point is to demonstrate the fine screening in the sorting plants, because often the people ask if very small packagings get lost during the sorting processes. And what you can see here is that in all modern plants that are built state-of-the-art in Germany, we have a cut size of 20 millimeters for a fine screening component. And this screen is built to ensure that small packaging units like caps of bottles and coffee creamer still remain in the material stream and do not pass the sieve. The second relevant sorting step is the eddy current separation to separate metallic and non-ferromagnetic components. So the separation is based on the induction of electrical currents in electrically conductive materials by a high frequency magnetic alternating field. And the precondition here for the separation is that the induced current flows indirectionally. That means that if we have an aluminium foil which is crimped into a ball, cannot be separated as well. Also that metallized films are not separated due to the fact that steamed aluminium foils are too thin to allow a direct magnetic field to be built. The next thing, which is very important for a differentiated sorting from a multi-material mixture, such as lightweight packaging, LVP, as we call it, or PMD, plastic, metal, and drink packaging, requires using sorting NRR separators according to the state of the art. The principle is that when plastics are illuminated, that they mostly reflect light in the near-infrared spectrum. The NIR sensor can then distinguish between different materials based on the way how they reflect the light. And for this purpose, the objects are separated and pass under a scanner. Halogen lamps with a high NIR content are used and the reflected spectrum is measured. On the next slide, I would like to show what does the camera see and what is made of it. With the NRR measurement, a spectrum adjustment for individual pixels is made. The result can be made visible in color for all pixels using a special software. So it's the classification image that you can see in the middle. It's a specific evaluation of the institute, of our institute. And the measurement results are converted then into control signals for the discharge control signal for the valve plug. This picture, you can see a third picture, valve control, which is also made visible in colors here. The control valves remain open until the object is hit by the airstream, and so the separation is performed. Each single pixel that you get from the detection is then compared to a reference spectra that is stored in the EDP program. We have also to take into account then, when we go further, all the significant process steps that come later after the sorting took place. And we can see, for instance, on the right-hand side for films, we have for the recycling plants, then normally the main processing steps, grinding, cleaning, density separation, and the melting processes. So all these other steps we have to take into account when we do the recyclability assessment. I would like to go a little bit more detail into our assessment catalog and say what's the methodology that stands behind. The basis is where we are doing the assessments are packaging specification and empirical analysis, and the procedure is built up that we do a material specific balancing on the basis of a reference process that represent the current state of the recycling technology. Then we run through an evaluation matrix under examination our packaging and do tests concerning the sortability of a packaging, the processability, and also the ability of praxis. The valuation parameter in the end is the recyclability, which is stated in a certain share, a gradual scale from 0 to 100%, which is of course very seldom. And the packaging is assessed without any filling material. What you can see here is that how we do our assessment. So we come directly from a process description and want to make a balance for the packaging to be assessed. What happens to the packaging when it has gone through all the process steps? That is the question behind. What is important is that the individual steps are connected into a series. That means if one of the steps is a 0 or a 0% is assessed, the final result is a 0 too. The percentage of recyclable material is determined first, means everything that is not valuable, recyclable material is deducted, and the path allocation that follows is a subordinate criterion here. So meaning if we have no collection or processing structure, if this is not available, the recyclability cannot be verified unless structures become available. This characteristics leads us to the question of the country differentiation, so the different national states for which the recyclability can be stated at the end. The next question is the packaging sortable in a targeted manner? So we have here to do the detection via NRR and test of the discharge behavior, per instance. The step technically recoverable evaluates crucial processes in the separation of substances. Per instance, this includes the melting behavior of plastics. Are there any melting losses, immiscible components, or even non-separable components that lead to significant degradation of the recyclate later. At the last point, systematic losses are evaluated. Per instance, the size criteria plays a role here, or rolling properties, per instance. If everything is fine, the packaging passes the assessment, the recyclability can be stated then in a percentage. What is the recyclable content of a packaging? For plastics, per instance, it is the PE or PP content. It's the first line, the first column here that is shown. For PP films, shares are deducted by a certain percentage due to the mechanical properties, due to the fact that only a small share of PP is allowed in certain applications when we go perhaps into blown film applications. So that is considered. And non-recyclable components are other plastics like or paper labels, adhesives, or lacquers, per instance. High quality recycling requires the separability of contaminants. We have 3 categories that are distinguished according to the quality of contaminants, which are shown in the first line here for films. We've published the categories because it's not so good readable here in our assessment and requirement catalog, perhaps for later reading. The category 1, per instance, these are components or contaminants that are separable by the treatment steps. The second one, category 2, are components that are not separable, but with no or minor impact on the recyclate properties. And category 3 are those ones that are not separable, but degrade the quality of the recyclate to uselessness. So this is a criterion for exclusion, means in case of Cat 3 contaminants, recyclability will be stated with a 0. That's again the picture showing our testing methodology with the NRR machine. And here the next example shows a non-recyclable or very poor recyclability recyclable structure as actual saturation in this slide. On the left-hand side, for a multi-layer structure with PET, reasons are among other things the used PET layer in the structure, the identifiability of the PO structure is not given, and the pouch becomes too heavy regarding the density criterion, our C5. The packaging type was optimized using 2 published examples, so we may mention them. Frosch with a pure PE-based structure, and the other one, Mowgli, with a pure PP structure. Another example for a C8 criterion is a PET-PR copolymer material. Here, this is an example why packaging cannot be identified as recyclable. PA is a contaminant of the category 3 because the material is not thermostable. PET flakes are heated up. When they are heated up, the flakes discolor in brown. For each packaging to be examined, the individual criteria are assessed and are documented then in a comprehensive test report. And if the packaging has passed, the test result of the recyclability of the packaging or the product is shown then in a certificate with a national reference.
Thank you very much, Sandra, for that interesting presentation and the clear explanation of HTP methodology and approach.
Thank you, Sandra, for your presentation. I am sure that our live audience have picked up a lot of useful information today. Now, as mentioned earlier, we are available to answer some of the questions that you have sent us. So I have the first question for you, Sandra. Can we expect that recyclable packaging solutions will be awarded with reduced EPR fees? And if so, do you have a timeline for that?
That can be expected, yes, because to the fact that Para 21 of the German Packaging Act has also laid down binding requirements in this respect. But these, as expected, remain ineffective because the special nature of the competition that we have in Germany between the EPR systems has not been taken into account when the law has been created. So the Institute Cyclos-HTP is currently investigating proposals for legislative optimization in a research project for the Federal Environmental Agency. And an effective incentive system is expected to be in place by 2022.
Thank you, Sandra. We have one more question for you, and it's about, do you expect that other countries in Europe, but not only Europe, will follow the example of Verpacke in Germany and adopt a similar national legislation?
We also expect that other countries follows, because when we look in Article 8 of the Waste Framework Directive, it's required there. This is also relatively easy to implement in EPR monopolistic structures. So when we talk about France, Italy, the Netherlands, and more recently also for Belgium, where incentives with high price differences for recyclability are also already in place. The still outstanding solution in Germany, we guess that this can certainly serve as a blueprint for national states that also have other EPR competition systems.
Very interesting, Sandra, and thanks for the explanation. I have another question. Can you briefly explain what is the main difference between HTP Cyclos methodology and other methodologies which also make reference to Verpacke law and its minimum recyclability requirements?
The main objective of our assessment has been to provide packaging manufacturers and brand owners with a legal basis according to the ISO 14021. So that they are able to claim recyclability. Our assessment reference is always the current technological standard from collection to the use of recycled materials for all type of packaging materials. So meaning that we do a material specific balancing that is performed represented by the actual current state of the recycling technology, based on packaging specifications, also as well as for empirical analysis. And I guess that one of the main differences is our experience and expertise, and we perform the assessment based on our knowledge that we have or that we build of 30 years of development and realization of sorting and recycling plans. Furthermore, as we already mentioned, as official appointed and sworn experts for packaging disposal, and we are the only ones that provide the balance sheet based metric scaling according to the ISO and the DIN standard. So recyclability is stated from us as gradual scale of recyclability with the national reference for those countries where the recyclability can be claimed.
Thank you, Sandra. We have a very interesting question from Greece. You said that you are certifying recyclability according to your own standards. Are the certificates accepted by state officials in different countries?
We do it now for 10 years and never have heard, never had become another opinion. So I think yes, of course, because the question is from Greece. Recyclability is always only there stated where we have the information that collection and recycling infrastructure is given. That's not meaning that perhaps certain structures are not existing, but we have not the knowledge at the moment. So it could be that some countries are missing and will be added later.
Thank you. I have one last question for you. For NIR sorting assessment, is it made in static or dynamic way?
NRR, it's done in a dynamic way with a conveyor belt where the packaging has a certain speed and is separated. It's dynamic.
Thank you, Sandra. I'll try, if we have time, just for one last question. And the question is, if metallized films are not sorted by eddy current, how are they sorted then?
Metallized films are normally also separated at a step before via the wind shifting, where every lightweight packaging is separated. And then there are some other sorting steps behind, like NIR, to make a pure LDPE film, and another part that we have in Germany where the film is separated into another material stream. But normally it's separated at this early stage via the wind shifting process.
Thank you very much. And we have received actually quite a number of questions, and we would be very happy to answer them all. But as said, we ran out of time, so we will be personally responding to your questions via email later. Once again, thank you, Sandra, for today's discussion, and we are truly honored to have you with us here on Dynamic Cycle Institute. Thank you.
Thank you.
Indeed, it has been an insightful discussion. Thank you very much, Sandra, for your presentation, and also Monica for being with us today. I would like to remind the audience that if you have any further questions, please feel free to reach out to us through our contact details. You may write to us at sustainability@ti-films.com, or for more information on Dynamic Cycle, you may visit dynamiccycle.ti-films.com. You may also follow us on our LinkedIn and Twitter pages for the latest updates, or you may easily search and filter through by using the hashtag Dynamic Cycle Institute. In name of Taghleef, we would like to thank all our speakers that we had the honor to host in our live sessions, and especially our audience who stayed with us during this first webinar series and gave us the opportunity to present Dynamic Cycle, our new sustainability initiative. We believe that along the value chain, we can all contribute and do our part in support of the circular economy and a more sustainable future. We would like to take this opportunity to wish you a happy holiday season and a joyful and prosperous new year. Stay safe, and we will see you again in our next DC webinar series.